Hello students, this is Professor Anup here. Welcome to my channel Decodenetworks. Today I'll be starting with my first video that is about signal system. We'll be starting with the subject signal system, right? And let's start now. So now the first question comes, what is meaning of a signal? Signal is nothing but what? When you think about signal exactly hota kya hai, right? Signal is nothing but what? Signal is something said to be information. See, from childhood, we have heard this word known as signal. When we heard signal, what exactly signal means? We have seen red light, yellow light, green light. That is a signal which gives you information, right? And the same in a different domain, always it gives you information. Now, signal is something physical quantity which varies with respect to the independent variable that is x. Now, I'll be starting. Check. So as I told you, when we say signal, that is a information. Always a signal gives a information. Now, if you think, okay, if a blink of a single eye, that is also a signal, right? It gives you a signal. Similar way, I say that signal is a quantity which changes with respect to the independent variable. Now, you people know that independent variable is something which is always on x-axis, right? That means what? You will be seeing x-axis as an independent variable. With respect to that, your amplitude changes. This is something amplitude, right? Now, when we say about the signal, the first thing which comes in mind, there are two types of signal. One is continuous time signal, one is discrete time signal. I'll explain you that. So when we say about the type, so one is continuous time signal and one is discrete time signal. Now, when we say continuous time, what is exactly meaning of a continuous time? Continuous time signal is that signal which is always continuous, which signal is not continuous, you think. So in engineering, in first semester, we start with a subject known as BEEE, Basic Electrical Engineering. There we start our first signal, that is nothing but AC sinusoidal signal. So you bring any appliances from the market, the first signal which you have to give, that is an AC signal, that is a power supply, right? 230 volt, 50 hertz, which normally works in India. Right, that is the AC signal, right? That is continuous time signal. Now, why it is said to be continuous? In a simple manner, I'll say you, continuous time signal is that signal which is present at any instantaneous time. That is what I mean to say. When I say CT signal, okay, suppose I say example, x of t, yeah, most important, CT signal, that is continuous time signal, say in a small short form you say as a CT, x of t. CT signal is always represented by x of t, right? X of t, suppose I say a sine omega t. What is this? This is a signal which we have seen in BEEE, a sinusoidal signal. How this signal is made? If we say this is that signal, right? This is a signal. A single waveform I have made with a positive cycle and a negative cycle. It starts with 0 and ends with 2 pi. Now, understand that what I'm trying to say. Continuous, first in the nature wise, you can say that it is continuous. See, right? It is continuous. Now, second thing, suppose I ask you, there are multiple time, there are infinite time between 0 to 2 pi. Suppose I say you, I need, let's say I need time at this. So what is time at this? Let's say this is t1. At time at this time, suppose I need an amplitude. So what is your amplitude? Let's say your amplitude is a1. Now suppose that another student asks me that, sir, I don't want at t1, suppose I need at t2. Okay, suppose another student tells me that at t2. So I say this is the amplitude. Okay, suppose one more student tells me that, no sir, I want something in negative cycle. So I say, let's say he is selling at t3, I'll say this is my amplitude. Let's name that as nothing but what? Minus of a3, as it is a negative. So what I'm trying to say you that, between 0 to 2 pi, you ask me amplitude at any time, always we can give, and that's it. That is something said to be nothing but continuous time signal, because you can give amplitude at any time, right? So always I simply say that continuous time signals are that signals which have instantaneous amplitude at any time. The time for this is denoted by small t. Yes, you can't use any other letter for that. CT signal is always something said to be with time t. Now coming to discrete time signal. Now we have heard something about ADC. Now, what is exactly ADC? Analog to digital converter. Simple, we think that, sir, there is an analog signal which gets converted. Now, what is the process? So, the process for this is sampling, right? Sampling is nothing but where you are making your analyzed signal quantized and giving it to the discrete signal, and then that signal is getting quantized and giving you a digital signal. Okay, see, try to understand what I'm trying to say. I am saying you that you have an analog signal, right? At every integer time, you are recording the amplitude at every integer time. Integer time means what? After 0, suppose I start with 0. After 0, I am recording time at first second, 1 second, then 2 second, then 3 second, then 4 second. Always at integer time, you will be getting amplitudes, and that is something said to be discrete signal. Now, this is my analog signal, right? This is my analog signal. Let's make a discrete signal for that. Now, first discrete signal is represented by x of n, right? And I am writing discrete version of this, which is a sine omega n. Simple. Okay. Now, let's make the signal. Now, when I make this signal, first, this is x of n with the discrete time n. Again, I would like to say you that, see, when you talk about n, it is a fixed letter which is used for discrete time. Now I'm making a discrete version of this. What I told you, I will be recording time only at integer. Okay, only integer time. So what is at 0? 0 amplitude is 0. Okay. The next I will be recording at 1. Let's say the amplitude, it is A1. Okay, let's say A1. So I am making a sample. This is something, this is a sample. This is a way to represent your discrete signal. You will be making a samples, that is simple line with denoting the amplitude by either arrow or either dot. I have made an arrow. I say, let's say this is nothing but what? A1. After that 2. At second, I'll be recording amplitude. Okay. Let's say A2. After that A3. After that, continuously I'll be recording the amplitudes. After that, let's say in the negative, right? And it ends here. What I'm trying to say, students, see, understand, you have seen the shape of the sinusoidal signal is same, but you have recorded only at discrete time, that is 3, 4, 5, 6, 7, 8, 9, 10. In the similar way, you can go till your signal you have it, but only at discrete time. If you see the shape, the shape of the signal is similar to sinusoidal, but you don't have information at any time. That means if I tell you after 0 where amplitude you are having amplitude at 1. After 1, 2. After 2, 3. If suppose a student is asking me, sir, what is amplitude at, let's say 1.5. Suppose he is asking me, sir, what is amplitude at 1.5? Can I tell you the information? Can I tell you the amplitude? No. Because in discrete signal you will be getting only at integer time. Is it clear? Okay, only at integer time. Now one more thing I like to see you. See, student also get confused that, sir, whether your amplitudes are also integer? No, amplitudes are same. The information what you get here, they are exactly same. Okay, so I mean to say that your amplitudes can be any number. It can be 2.5, 1.5, anything, any point number, any number. It can be integers also, but they are not only integers. Integer is only time. So this is a difference between a continuous time signal and a discrete time signal. Hope you are clear with this. Okay. So now, for example, see, we have many signals. Okay. When we say in continuous time signal, let's say our standard signal is unit step signal, ramp signal, parabolic signal, sinusoidal signal, triangular signal, square signal, rectangular signal. There are many signals. Okay. Now, any signal is always represented in continuous time as well as in discrete time. Okay, now we will be looking into that. So my first topic would be, my topic number 1 would be standard elementary signals. Now when we say elementary signal, that means which signal we have? We have three signals. Okay, first is unit step, second is impulse, and the third is ramp signal. Okay, so always we have to understand these three signals. So first signal, I say unit step signal. Okay, when we say about a unit step signal, first understand this signal will be in CT, that is continuous time, as well as it will be in DT. So when we say as U of t, okay, it is U of t. T for CT, it's a continuous time. First I'll explain you U of t, then I'll explain you as well as U of n. First, the definition is U of t, the naming is U of t. Now what is exactly U of t? U of t is having amplitude 1. So amplitude 1 at what time? Your time is basically t greater than equal to 0. That means what? From 0 to infinity, this signal is always having an amplitude 1. Why 1? Because we have said unit step. Now in the starting phase, we will understand we have written unit, that's why unit step. Further, yes, you can get it of any amplitude. Okay. So, and what about the negative, sir? So at the negative, it is 0. So this is your functional representation. Try to understand. This is functional representation of signal. You have written an equation, right? That's why it is something said to be functional representation. Okay, you're clear with this? Now let's make a graphical representation. Now when we make a graphical representation, make a y-axis, make x-axis. This is t. Okay, let's say I'm coming here. This is starting at minus infinity. This is 0, and your time ends at infinity. Now what you understood that for t greater than equal to means at 0 also. At 0 also you have amplitude. What is your amplitude? 1. So coming from minus infinity, your signal is 0. See, less than 0 is 0. So I will be making 0 till here. Then it will take amplitude of 1 and then it will maintain amplitude of 1. Understand students, it will maintain amplitude of 1 till infinity. Okay, till infinity. It is an infinite signal. Hope you are clear with this. Now this was a CT version. This was nothing but what? CT version. Now coming to DT version. Okay, so DT version is U of n. What it is? U of n. Now coming to U of n, again let's write the representation. U of n is again 1 where n greater than equal to 0. Whenever your n is less than 0, your signal is 0. This is your DT version. Very simple. Kuch nahi, exactly you wrote it in the same way, right? Now coming to this was functional representation. Okay, most important, I forgot to say, in the y-axis you have to write U of t. Okay, coming to the DT version, what you will do? This is n, this is U of n, right? Understand, we have DT version. DT version means what? Only at discrete time. So let's write the time first. 0, 1, 2, 3, 4, 5. In the similar way, it will go to infinity, and also it will come from minus infinity. Okay, what we need to make? Signal n greater than equal to 0. So at 0 it has an amplitude of what? 1, 1, 1. This is 1. Yes, you can give it by arrow also. Okay, 1. This is 1. This is 1. Clear? 1, 1, 1, 1, 1, 1. See, you can represent by dot or you can represent by arrow. That's not a problem. So this is something said to be nothing but what? U of n. Okay, that is discrete version, and this was something said to be CT version. Okay, I just write here DT. So this was my first signal, that is unit step signal. Now let's go with the second signal. Okay, now going with the second signal is unit impulse signal. What is unit impulse signal? Let's first say in the discrete version, in continuous time version. In CT, it is represented by del of t. This is del of t. Okay, del of t is a signal which is having amplitude of 1 only at t equal to 0. So whenever t is not equal to 0, your signal is 0. Simple. So how to make this signal? Very simple. This is del of t. This is something t, right? At 0, it is having amplitude of 1. That means what? Try to understand. In CT signal, you will just make a single line. of 1. It is not a discrete version. Try to understand. As signal is having amplitude of 1 only, that's why we are making a straight line. So it means what? From 0, the signal started started straight and it ended to 1. That's it. Because rather than 0 at any time, your signal is 0, right? Sir, t equal to 0 pe your amplitude is 1. Understood? Very clear? Now coming to the next. This is del of t with the functional representation. Now coming to dt. Now when I come to dt, it is del of n. Now what is del of n? It is 1 when n is equal to 0. When n is not equal to 0, your signal is 0. Okay. Now, very fantastic thing you have to understand. See, this is only one signal. In CT or DT, it looks same. Okay. Unfortunately, it looks same, but they are not same because your time is different. Here, we will be saying this is del of n with n and this is 0. Okay. So here I will say what? Again, having amplitude of 1. Yes, it is looking same, but the both signals are different. Okay. Hope you are clear with this. Okay, this was unit impulse signal. Now, going with the third. Now, third is unit ramp signal. Okay, ramp. We know ramp. Ramp is something what? Which has an angle, right? It has an angle, ramp, right? Wherever you have seen for disabled people, you have a ramp, no? Right? Your signal looks exactly the same. It has a ramp. See, now, first in CT, okay, it is denoted by R of t, which is nothing but what? T, where t is greater than equal to 0. When t is less than 0, your signal is 0. See, try to understand with respect to maths, okay. With respect to the maths, I can say, suppose for example, I say you that what is x is equal to y line? What is the line how you make for x equal to y? When equation is x equal to y, that means what? You will be getting something like this, right? This is nothing but something said to be ramp, and this is something equation of x equal to y, correct? Now understand, it has a slope. A ramp signal is always represented by a slope. From slope you understand. Now you people know what a slope. Slope is nothing but what? Normally represented by m, right? We have also heard that m is equal to tan theta. So this is your slope, right? This is x equal to y. Now if you see carefully, r of t is what? R of t is y-axis, right? R of t is y-axis where you represent amplitude. T is x-axis. So when we make this signal, we make it in this manner. This is t, this is r of t. Okay, understand? This is r of t equal to t only at t greater than 0. Here where you made y equal to x, here you made it both sides because no limits were mentioned that it is going from positive, it is only in positive or whether it is only in negative. It is mentioned that here it is only in positive, t greater than equal to 0. That means starting at 0 to infinity, you have ramp, you have a signal with slope as 1. Hope you are clear with this. Yes, it is having amplitude, but it is never made with respect to amplitude. It is made with respect to the angle, with respect to the slope. So your slope is what? 1. That's why this is my signal. Yeah, it will be continuous till infinity. It is also an infinite signal. Okay. Now, when we make discrete version of this, suppose I say dt, be represented by r of n, which is equal to n. N is greater than equal to 0. N is less than 0. Your signal is 0. Okay. Understand very carefully. Made a y-axis, x-axis. This is n. This is r of n. Okay. Clear? Now, when we say 0, okay. Understood. Let's work together. Go and substitute 0 here. So r of 0, यहाँ क्या आएगा? You will substitute 0 here, right? That means what? At 0, your amplitude is 0. Correct? After going, next is what? 1. Go and substitute here. R of 1. You will substitute here 1. Right? That means your amplitude is 1. That's why it is said to be a linear signal. The meaning of a linear signal is what? whenever you say that your x is 1, your y is 1, that means it is a linear signal. If your x is increasing, your y is also increasing. That's why it is said to be a linear signal with slope 1. So at 1, you can say amplitude of 1. Okay, let's write first all time 2, 3, 4, 5. Okay, at 2, you will make amplitude 2. This was 1, this was 2, 3, 4, similar. Okay, so this is a signal which obviously it will go till infinity. This is something said to be what? A DT signal as a ramp. Okay, hope you are clear with this three signal. Now let's understand the relationship between them. Okay, let's understand the relationship. Now the first, okay, this is the topic number 2. I say relationship between, first let's say R of t and U of t. Now try to understand, I will define the relation in t, but the same relation it can be worked in dt also, okay, discrete time also. Okay, first let's represent a ramp signal. What is ramp signal? R of t, that is equal to what? T greater than equal to 0, t is less than 0, your signal is 0, right? Lovely. This is R of t. Now understand, students, let's differentiate both sides. With respect to t, when I differentiate this, differentiate means derivative, d by dt of R of t, that is equal to dt by dt. That means, I mean to say, understand, you need to differentiate this. So d by dt of t, where in the time of t greater than equal to 0, and differentiation of 0 in t less than 0. Okay, what you will get? If you check right hand side, d by dt of t is nothing but 1, d by dt of 0 is 0. This is nothing but t greater than equal to 0, this is t less than 0, and the left hand side was d by dt of R of t. Now if you see, students, what is this? What is this? This is nothing but what? Unit step signal. Unit step signal ka right hand side yahi tha na, right? 1 and 0. That means I can say when you differentiate R of t, the right hand side what you get, that is U of t. This is the relation. Okay, you can say in this manner, or else you can also say differentiation goes that side. R of t is nothing but what? Integration of U of t with respect to dt. You can say in this manner also. Hope you are clear with this first relation. Let's check the next relation, students. Okay, let's check the next relation. Now, third, relationship between U of t and del of t. Now, this is very interesting. Okay, check. I first mentioned U of t. What is U of t? U of t is one where t greater than equal to 0. T less than 0, signal is 0. Okay, let's make U of t. This is U of t. Right, at 0. This is your signal having amplitude of 1, right? Starting at minus infinity to 0, signal is 0. 0 getting amplitude of 1, pehle 1 tak jayega, and then it will maintaining the amplitude of 1 till infinity. Okay, try to understand what I'm trying to say. Okay, what I'm trying to say, from minus infinity to 0, do you have any change? Kuch bhi change ho raha hai kya? Nahi, it is continuously with 0 amplitude. So I can mention that your amplitude from minus infinity to 0 is 0. Okay, at 0 point it changed and it went till amplitude of 1. After 0 to infinity, again it is constant, right? Just after 0, that can be any time, right? There are infinite time, but just after 0, again it is maintaining an amplitude of 1, which is constant. Now try to understand, I am differentiating this both sides. Now when I differentiate this, I write differentiate with respect to time both sides. So when I say differentiate with respect to time both sides, what I can say here, there is no change, constant. Constant ka differentiation what? 0, right? At 0, it changed the amplitude from 0 to 1. So rate of change of amplitude happened only at 0. Whatever amplitude changed, that was only at 0. Simple. So that means you can say at 0 there was a change. After 0, again it was constant. Again it was constant. That means when you differentiate from minus infinity to 0, you will be getting a differentiation 0 here, right? Here differentiation will be 0. After 0, just after 0 to infinity, again your amplitude is something which is constant. Again your differentiation will be 0. That means what? Understand, students, you got 0 at this, from minus infinity to 0, right? From 0 to infinity, again it is 0. So where change happen? Change happen only at, what I can say, only at 0. So which is that signal? From 0 it went till amplitude of 1, right? So what I can say, which signal is there which is getting an amplitude as 1 at 0? Only one signal is that is impulse signal. So I can say differentiating u of t, you simply get what? Del of t. See, I know from direct differentiation you will be getting 0 here. You don't need to do direct differentiation because there are infinite time. You need to understand with respect to time. टाइम के रेस्पेक्ट में जब समझोगे तब आपको समझेगा दैट डिफरेंशिएशन इज मेड टू चेक, और टू चेक व्हाट? रेट ऑफ चेंज ऑफ एनीथिंग विद रिस्पेक्ट टू अनदर, rate of change of one variable with respect to the another variable, right? That's why you are checking your amplitude is changing only at 0, and at 0 it is getting an amplitude of 1, which is a signal which is getting an amplitude of 1, that is del of t. Hope you are clear with this relationship. You can also say that u of t is also integration of del of t with respect to dt. Okay, so either you can say this or either you can say this. Hope you are clear with this. Okay, hope you are clear with the relationship.